You're floating in the vast darkness of the ocean, nothing more than a tiny embryo suspended inside a protective capsule. Your mother laid you here weeks ago, along with hundreds of your siblings, in long, translucent strings that drift with the current. She didn't stick around to see what happened next. Once the eggs were fertilized and deposited, her job was done. You're on your own from the very beginning. Inside your capsule, you're developing fast. Your body is forming piece by piece, tentacles stretching out, eyes taking shape, organs settling into place. The yolk sac attached to your developing form provides everything you need for now, but that won't last forever. Around you, some of your siblings aren't making it. Their capsules have gone cloudy, their development stalled, but you keep growing, keep changing, preparing for the moment when you'll break free into the open water. Then it happens. The capsule splits, and you push through, your tiny tentacles working instinctively as you emerge. You're barely the size of a grain of rice, translucent and fragile, drifting in the current with nothing but basic instincts to guide you. Welcome to life as a squid. You've just been born into one of the ocean's most unforgiving environments, and every single day from now until the moment you die will be a constant battle for survival. But here's the thing about your species. You're not just another mindless sea creature floating around hoping for the best. You're about to become one of the ocean's most intelligent predators, equipped with abilities that would make science fiction writers jealous. You can change color instantly, become invisible, communicate through living light shows, and solve problems that would stump creatures with much larger brains. Your body is a masterpiece of evolution, built for speed, stealth, and survival in ways that most animals can only dream of. Over the next few months, you'll grow from that tiny transparent hatchling into a sophisticated hunter capable of taking down prey twice your size. You'll learn to navigate complex social hierarchies, master the art of deception, and develop survival strategies that have kept your kind alive for millions of years. But you'll also face constant threats from predators who see you as nothing more than a quick meal, environmental challenges that can kill you in seconds, and competition from your own kind that can turn deadly without warning. This is your complete life story, from the moment you break free from your egg to your final moments in the deep. It's a journey filled with incredible transformations, life or death encounters, and behaviors so complex they're still puzzling scientists today. You'll experience everything from the vulnerability of youth to the power of maturity, and through it all, you'll be operating with intelligence levels that rival some of the smartest creatures on the planet. So let's dive into the extraordinary world you've just entered, where survival depends on your ability to think fast, adapt quickly, and master skills that most animals never even attempt. Your life as a squid is about to begin, and trust me, it's nothing like what you might expect. Right now, as a newly hatched squid, you're part of the plankton, that vast community of small organisms drifting through the ocean's upper layers. You can't swim very well yet, so you're mostly at the mercy of the currents. Your body is almost completely transparent, which is your first line of defense. Predators scanning the water for an easy meal might look right past you without noticing you're there, but transparency only goes so far. Fish, jellyfish, and other hungry creatures are constantly filtering water through their mouths, and if you get caught in that flow, it's over. You need to start eating, and you need to start now. Your yolk sac is nearly depleted, and your tiny body is burning energy just trying to stay alive. Your first meals are microscopic, tiny copepods and other zooplankton that are barely visible to the naked eye. Hunting them requires precision you don't quite have yet. You extend your tentacles, trying to grab onto anything edible that drifts within range. Most of your attempts fail. The copepods are fast and surprisingly good at dodging your clumsy grabs. But hunger is a powerful motivator, and you keep trying. When you finally manage to catch something, the relief is immediate. You pull the tiny creature toward your mouth, where your beak, yes, you have a beak like a bird, hidden inside those soft tentacles, tears it apart. It's not much, but it's enough to keep you going for another day. Every successful hunt teaches you something new about timing, about predicting where your prey will move, about using your tentacles more effectively. As you grow, your hunting skills improve rapidly. Within a few weeks, you've figured out how to coordinate your tentacles, how to anticipate your prey's movements, and how to strike with the kind of precision that will serve you well throughout your life. But with growth comes new challenges. You're getting too big to rely on transparency alone, and larger predators are starting to notice you. That's when you discover one of your most remarkable abilities. The skin covering your body is packed with specialized cells called chromatophores, each containing different colored pigments. By expanding and contracting these cells, you can change your appearance in milliseconds. One moment you're transparent, the next you're mottled brown and green like a piece of floating seaweed. It's not just camouflage, it's active deception, and you're getting better at it every day. You learn to read your environment, matching not just the colors around you, but the patterns and textures too. When you settle on a rock, your skin takes on the rough, mottled appearance of the stone beneath you. When you drift near some kelp, you become long and flowing, like the plants swaying in the current. It's like having a full-body costume that changes instantly based on your surroundings. But color change isn't just about hiding. You're also learning to use it for communication. When you encounter another young squid, patterns ripple across your skin, waves of color that convey information about your intentions, your size, your readiness to fight or flee. It's a complex language written in living light, and you're becoming fluent without even thinking about it. Your body is changing in other ways too. Your tentacles are getting longer and stronger, lined with rows of suckers that can grip with surprising force. Each sucker is ringed with tiny teeth, perfect for holding on to struggling prey. Your eyes, which started as simple light detectors, are developing into sophisticated organs capable of seeing polarized light and detecting the faintest movements in the water around you. Most importantly, your brain is growing. Unlike most invertebrates, which have simple nervous systems spread throughout their bodies, you're developing a centralized brain that's remarkably complex. It's still small, it will never be huge, but it's incredibly efficient, packed with neurons, and capable of processing information in ways that would surprise creatures many times your size. This growing intelligence changes everything about how you approach the world. You're not just reacting to stimuli anymore. You're planning ahead, solving problems, learning from experience. When you encounter a new type of prey, you don't just attack blindly. You watch it first, studying its movements, figuring out its weaknesses, developing a strategy that maximizes your chances of success while minimizing your risk. You're also learning about the ocean itself, the rhythms of day and night, the patterns of current and tide, the locations where food is most likely to be found. During the day, you tend to stay deeper, where the dim light makes your camouflage more effective. At night, you rise toward the surface, following the great vertical migration of plankton that brings food up from the depths. This daily rhythm becomes the foundation of your life. Dawn and dusk are feeding times when the water is full of movement and opportunity. Midday is for hiding, for conserving energy, for avoiding the sharp eyes of predators that hunt by sight. Midnight is for traveling, for covering distance while the darkness provides protection. But even with all your developing skills and intelligence, you're still vulnerable. The ocean is full of creatures that see young squid as ideal prey, not too big to swallow, not yet clever enough to be truly dangerous. Fish patrol the water columns, looking for exactly your kind of target. Jellyfish that drift through your territory with stinging tentacles that can paralyze you in seconds, as even other squid, older and larger than you, might decide you look like a convenient snack. Your best defense is still not being seen. You've become a master of disguise, able to blend into almost any background the ocean provides. But when stealth fails, you have other options. Your body is built for speed, streamlined and muscular, capable of jet propulsion that can launch you through the water faster than most predators can follow. The secret is your siphon, a funnel-like organ that you can aim in any direction. By forcing water through it at high pressure, you create thrust that rockets you backward, forward, or sideways with startling speed. It's not efficient for long-distance travel, but for short bursts, for escaping sudden danger, or making lightning-fast attacks, it's perfect. You're also developing another crucial skill, the ability to assess threats and opportunities quickly. When something moves in your peripheral vision, you don't panic immediately. Instead, you analyze. Is it bigger than you or smaller? Is it moving toward you or away? Does it behave like a predator, prey, or neutral presence? These split-second decisions often mean the difference between life and death, and you're getting better at making them correctly. By now, you've survived longer than many of your siblings. Some were picked off by predators in their first days. Others failed to adapt to the constant challenges of finding food and avoiding danger. But you've made it through the most vulnerable period of your life, and your survival skills are sharpening with every encounter. You're no longer just drifting with the plankton. You've become an active participant in the ocean's complex ecosystem, a predator in your own right, capable of making choices that determine your fate. Your intelligence continues to grow, your body continues to develop, and your understanding of the world around you becomes more sophisticated every day. The open ocean stretches endlessly in all directions, full of mysteries, dangers, and opportunities. You've learned the basics of survival, but there's so much more ahead: territories to claim, rivals to face, prey to hunt, and predators to outwit. Your transformation from helpless hatchling to capable hunter is just the beginning of a remarkable journey through one of the planet's most challenging environments. But surviving as a juvenile is only the first test. Soon, you'll need to find a place to call home, establish yourself in the competitive world of adult squid, and master skills that will determine not just whether you live or die, but how successfully you can navigate the complex social and environmental challenges that lie ahead. The open water has been your world for months now, but something is changing. Your body is growing rapidly, and with that growth comes new needs, new instincts, new dangers. You can't just drift forever. The time has come to find a place where you belong, somewhere you can hunt more effectively and avoid the constant threat of being someone else's dinner. You start moving toward the seafloor, following an instinct you don't fully understand yet. The descent takes you through different layers of the ocean, each with its own challenges. The water gets colder as you go deeper. The pressure increases. The light fades until you're navigating mostly by touch and the subtle electrical fields given off by other living creatures. Down here, the rules are different. The bottom of the ocean is like a vast underwater landscape, rocky outcroppings, sandy plains, forests of kelp and coral, deep trenches that disappear into absolute darkness. This is where you'll spend most of your adult life, and finding the right neighborhood is crucial. You're looking for something specific, though you wouldn't be able to explain what. A place with good hunting grounds nearby, enough hiding spots to disappear when larger predators show up, rocky crevices where you can squeeze your soft body to rest safely, not too close to other squid territories, but not so isolated that you'll never encounter your own kind. When you find it, you know immediately. It's a rocky reef with plenty of caves and overhangs, surrounded by sandy areas where crabs and fish like to forage. The water flow is good, bringing fresh oxygen and carrying away waste. Most importantly, it feels defensible, a place you can claim and hold against challengers. But claiming territory isn't just about finding an empty spot. Other creatures already live here, and they're not particularly interested in sharing. Your first challenge comes from a mantis shrimp that's made its home in the cave you want. These creatures are small but incredibly dangerous, with club-like appendages that can strike with the force of a bullet and eyes that can see types of light you can't even imagine. The mantis shrimp sees you coming long before you're ready to fight. It positions itself at the entrance to the cave, those powerful clubs cocked and ready. You could try to force your way in, but those clubs could shatter your soft body in a single hit. Instead, you wait. You use your intelligence to solve the problem rather than your strength. You notice that the mantis shrimp leaves its cave at certain times to hunt, following a predictable pattern. While it's gone, you explore the area more carefully. There are other crevices nearby, smaller ones that the mantis shrimp couldn't use, but that are perfect for your flexible body. You don't need to fight for the main cave. You just need to find an alternative that works even better. Your new home is perfect. It's a narrow crack in the rock that opens up into a small chamber, invisible from the outside, but spacious enough for you to turn around and rest comfortably. The entrance is so small that most predators couldn't follow you in, but you can squeeze through easily thanks to your soft, boneless body. From this secure base, you start establishing your hunting grounds. The area around your cave becomes your territory, and you learn every inch of it. You memorize the location of every rock, every plant, every hiding spot where prey might lurk. You figure out the timing of the tides, when different types of fish are most likely to pass through, where the currents bring the richest concentrations of food. Your hunting style is nothing like the frantic grabbing of your juvenile days. You've become a patient ambush predator, capable of waiting motionless for hours until the perfect opportunity presents itself. When a fish swims too close, you don't rush. You calculate its speed, its direction, the exact moment when it will be most vulnerable. Then you strike with devastating precision. Your tentacles shoot out like springs, grabbing the fish before it can react. Your suckers lock onto its scales, and those tiny teeth bite deep, ensuring it can't escape. If the fish is large enough to fight back, you have other tools. Hidden in your mouth is that parrot-like beak, capable of cracking through shells and bones with ease. A quick bite to the right spot, and even a struggling fish goes limp. But you're not just a mindless killing machine. You're selective about your targets, choosing prey that gives you the best return on your energy investment. Small fish aren't worth the effort unless they're extremely easy to catch. Large fish might fight back too vigorously, risking injury that could be fatal in an environment where weakness attracts predators. You've learned to target the middle ground, prey that's substantial enough to be worth hunting, but not so dangerous that the hunt becomes a life-threatening gamble. Your reputation in the neighborhood is growing. Other creatures are starting to recognize you as a threat, giving your territory a wider berth. Fish that once swam carelessly through your hunting grounds now move more cautiously, their behavior patterns shifting in response to your presence. It's a sign that you've successfully established yourself as a legitimate predator in this ecosystem. But success brings new challenges. Other squid have noticed your prime real estate, and some of them think they might be able to take it from you. Your first territorial dispute comes from a squid roughly your own size, one that's been living in a less desirable spot nearby and has decided your cave looks more appealing. The confrontation starts with posturing. Both of you change colors rapidly, your skin flashing through patterns that communicate aggression, dominance, territorial claims. It's like an argument conducted entirely through shifting patterns of light and color, each trying to convince the other to back down without an actual fight. Your opponent spreads its tentacles wide, making itself look as large as possible. Its skin turns dark and mottled, a pattern that signals serious intent to fight. You respond in kind, your own tentacles extending, your body darkening to an almost black coloration that makes your intentions unmistakably clear. For several minutes, you circle each other, looking for signs of weakness or hesitation. This is as much a psychological battle as a physical one. Whoever shows doubt first will likely lose, even if they're physically capable of winning. Your developing intelligence serves you well here. You're not just reacting instinctively, but actively trying to read your opponent's behavior, looking for tells that might give you an advantage. The actual fight, when it comes, is brief but intense. You and your rival crash together in a tangle of tentacles, each trying to get a grip on the other while avoiding being grabbed in return. Your suckers lock onto its skin while its suckers lock onto yours. For a moment, you're locked in a wrestling match that could go either way, but you have advantages your opponent doesn't. You know this territory intimately, every rock, every current, every hiding spot. When the fight moves near a sharp outcropping, you use it to your advantage, maneuvering your rival into a position where the rock scrapes against its soft skin. The pain and distraction give you the opening you need to gain a better grip. Your opponent realizes it's losing and tries to escape, jetting away with its siphon at maximum power. You don't pursue, you've made your point. The other squid retreats to its original territory, and word spreads through the local squid community that your cave is well defended. You won't be challenged again for quite some time. With your territory secure, you can focus on perfecting your hunting techniques. You're not just grabbing prey randomly anymore. You're developing specialized strategies for different types of targets. Crabs require one approach, their hard shells and powerful claws demanding caution and precision. Fish need another strategy entirely, their speed and agility requiring you to think several moves ahead. You become particularly skilled at hunting in low-light conditions. Your eyes, now fully developed, can detect the faintest movements in near total darkness. You learn to read the water itself, the subtle pressure waves that indicate something swimming nearby, the chemical traces that tell you what kind of creature passed through recently, the electrical fields that every living thing generates. One of your most effective techniques involves using your environment as a weapon. When hunting near rocky areas, you learn to position yourself so that struggling prey gets scraped against sharp surfaces, wearing down their resistance. In sandy areas, you use clouds of sediment as cover, striking from within the murk before your targets know you're there. Your intelligence continues to develop in ways that surprise even you. You start recognizing individual fish that frequent your territory, learning their habits and preferences. Some fish always take the same route through your hunting grounds. Others vary their patterns, but still follow predictable rules. This knowledge lets you set more effective ambushes, positioning yourself exactly where your prey is most likely to appear. You also begin to understand the complex relationships between different species in your ecosystem. You notice which fish are afraid of which predators, how they react to different types of threats, what times of day they're most vulnerable. This information becomes part of your hunting strategy, allowing you to exploit not just individual weaknesses, but the entire web of interactions that governs life in your territory. Your body continues to change as well. Your tentacles grow longer and more muscular, capable of reaching farther and gripping more tightly. Your skin becomes more sophisticated, able to produce more complex color patterns and textures. You can now mimic not just the basic colors of your environment, but specific textures: the rough surface of a rock, the smooth curve of a shell, the flowing movement of seaweed. But the most significant changes are happening in your brain. You're developing what scientists would recognize as genuine problem-solving abilities. When faced with new challenges, you don't just rely on instinct. You experiment. You learn from failure. You adapt your strategies based on results. This intelligence becomes crucial when a new threat enters your territory. It's a moray eel, a formidable predator with powerful jaws and an aggressive temperament. Eels like this one are known squid killers, and this one has apparently decided your neighborhood looks promising for hunting. The eel is too large and dangerous for you to fight directly, but you can't just abandon your territory either. You've invested too much time and energy establishing your claim here. Instead, you use your intelligence to find a solution that doesn't involve direct confrontation. You study the eel's behavior, learning its hunting patterns and preferences. You notice that it tends to hunt in specific areas at specific times, following routes that have become habitual. Armed with this knowledge, you adjust your own behavior to avoid direct encounters, while still maintaining control of your territory. When the eel is active in one area, you hunt in another. When it retreats to its den during certain hours, you reclaim the spaces it was occupying. It's a delicate dance of avoidance and timing, requiring you to constantly monitor the eel's location and activities while still finding enough food to sustain yourself. The strategy works. Over time, you and the eel establish an unofficial truce, each of you using different parts of the territory at different times. It's not ideal. You've lost some of your best hunting spots, but you've managed to survive and maintain your claim without risking a fight you might not win. This experience teaches you valuable lessons about coexistence and compromise. Not every problem can be solved through aggression or direct action. Sometimes survival requires flexibility, adaptation, and the willingness to accept less than perfect solutions. Your territory is established, your hunting skills are sharp, and you've learned to navigate the complex social dynamics of your underwater neighborhood. But as the months pass, something deeper begins to stir within you. Your body is changing again, not just growing larger, but transforming in ways that signal a fundamental shift in your life's purpose. You're reaching sexual maturity, and with it comes a whole new set of instincts and challenges. Your appearance begins to change subtly. Your colors become more vibrant, your patterns more complex. Males of your species develop specialized tentacles designed for reproduction, while females grow larger and more robust to carry eggs. These changes don't happen overnight, but they're unmistakable signs that your juvenile phase is ending. The urge to find a mate starts as a distant pull, like hunger, but different. It's not something you can satisfy with food or ignore through willpower. Your brain, already sophisticated by invertebrate standards, begins dedicating more processing power to social interactions and reproductive behaviors. You find yourself paying attention to other squid in ways you never did before, analyzing their size, their health, their potential as partners. But finding a mate isn't as simple as swimming up to another squid and expressing interest. Your species has complex courtship rituals that require intelligence, timing, and no small amount of courage. Males must prove their worthiness through displays of strength, intelligence, and genetic fitness. Females must evaluate potential partners carefully, since choosing poorly could mean wasting precious energy on inferior offspring. If you're male, your first challenge is competing with other males for the right to court females. This isn't just about size or strength, it's about demonstrating superior intelligence and resourcefulness. You begin seeking out other males, not to fight them directly, but to engage in complex competitions that test every aspect of your capabilities. These competitions take many forms. Sometimes it's about solving puzzles. Who can figure out how to extract a crab from a particularly difficult hiding spot, or navigate a complex maze of rocks to reach food? Other times it's about stealth and camouflage, contests to see who can remain invisible longest while moving through open water, or who can mimic environmental features most convincingly. The most intense competitions involve direct displays of pattern-making ability. You and your rivals position yourselves in clear water and begin what can only be described as a light show battle. Waves of color ripple across your skin in increasingly complex patterns. Stripes transform into spots, which morph into geometric designs that pulse and shift with mathematical precision. It's not just random flashing. Each pattern conveys specific information about your health, your intelligence, your genetic quality. The more complex patterns require significant neural processing power to generate and control. A male who can produce intricate, rapidly changing designs while maintaining perfect bodily control is advertising his superior brain development to any females watching. You discover you have a talent for these displays. Your patterns are crisp and well-defined, your transitions smooth and dramatic. When you generate a spiraling wave pattern that travels from your head to your tentacle tips, other males struggle to match the complexity. Your skin becomes a living canvas for expressions of intelligence and genetic fitness. But visual displays are only part of the courtship process. You must also demonstrate practical skills that prove you'd be a valuable partner. Hunting prowess is crucial. A male who can't catch food efficiently won't be able to support a female during that energy-intensive egg-laying period. You begin hunting more aggressively, not just for your own needs, but to show off your capabilities to any females who might be watching. Your hunting style evolves to become more theatrical, where once you were content with efficient, understated kills, you now employ techniques that showcase your speed, precision, and intelligence. You'll track a fish through complex underwater terrain, using every rock and plant as cover, before striking at the perfect moment with maximum dramatic impact. You also start collecting trophies, the shells of particularly difficult prey, unusual objects that demonstrate your ability to explore and acquire rare resources. These collections serve as advertisements of your capabilities, visible proof that you're not just another average male, but someone worth considering as a mate. When you finally encounter a receptive female, the real challenge begins. Females are larger than males and significantly more dangerous during mating season. Their increased size makes them formidable opponents, and their heightened aggression means that approaching at the wrong time or in the wrong way could be fatal. You must read her signals carefully. Her color patterns will tell you whether she's receptive to courtship, already mated, or in a mood to attack anything that comes too close. The difference between these states can be subtle, a slightly different shade of red, a pattern that pulses at a different frequency, tentacles held at a particular angle. When you identify a female who seems receptive, you begin your courtship display at a safe distance. Your skin erupts in your most impressive patterns, complex geometric designs that showcase your neural processing power, flowing color transitions that demonstrate fine motor control, aggressive displays that prove your strength and dominance over other males. The female watches critically, her own skin displaying patterns that indicate her evaluation of your performance. She might mirror some of your colors, signaling interest, or flash warning patterns that tell you to keep your distance. This initial phase can last for hours, with both of you engaged in an intricate dance of visual communication. If your displays meet her standards, she'll allow you to approach closer. This is where the real danger begins. Female squid during mating season are notoriously cannibalistic, and many males don't survive the encounter. You must time your approach perfectly, moving in when she's displaying receptive patterns, but ready to retreat instantly if her mood changes. The actual mating process is brief, but requires precise coordination. You must transfer a packet of sperm using a specialized tentacle while avoiding her powerful arms and potentially lethal beak. One wrong move, one moment of inattention, and you could become her next meal instead of her mate. If you're female, your experience is quite different, but no less complex. Your larger size and increased aggression during mating season give you more control over the process, but also more responsibility. You must evaluate potential mates, not just for their immediate attractiveness, but for their genetic quality and their ability to contribute to your offspring's success. Males will approach you regularly, each putting on elaborate displays designed to impress you. Your job is to see through the showmanship, to evaluate their true quality. A male with spectacular color displays might still be weak or unhealthy. One with impressive hunting trophies might have stolen them from another male's collection. You develop sophisticated criteria for evaluation. You watch how males move through the water. Smooth, efficient motion indicates good health and neural development. You observe their problem-solving abilities when they encounter obstacles or challenges. You pay attention to their behavior around other males, looking for signs of dominance and confidence. The most important factor is genetic compatibility. Your species has evolved mechanisms for detecting genetic diversity, and you're instinctively drawn to males whose genetic makeup complements your own. This isn't conscious knowledge. You can't analyze DNA sequences, but your sensory systems can detect chemical signatures that indicate genetic fitness. When you find a male that meets your standards, you signal your receptiveness through specific color patterns and body postures. You allow him to approach, though you remain ready to attack if he proves disappointing or threatening. The courtship process gives you multiple opportunities to change your mind and reject suitors who don't maintain their initial promise. Successful mating is just the beginning of your reproductive responsibilities. As a female, you must now prepare to lay eggs, a process that will consume enormous amounts of energy and leave you extremely vulnerable. You begin eating more aggressively, building up the nutritional reserves you'll need for egg production. Your body starts changing in preparation for reproduction. Your reproductive organs develop and expand, and you begin producing the proteins and other materials that will form your eggs. This process is metabolically expensive. You need to consume significantly more food just to maintain your basic bodily functions, plus extra to support egg development. You also begin seeking out the perfect location for egg laying. This isn't a decision you can make casually. Your eggs will need protection from predators, adequate water flow for oxygen exchange, and the right temperature conditions for proper development. The location you choose will largely determine your offspring's chances of survival. You explore your territory and beyond, examining potential egg-laying sites with the same careful attention you once devoted to selecting your hunting grounds. Rocky crevices offer protection but might not have adequate water circulation. Open areas have good flow but leave eggs exposed to predators. You need to find the perfect balance. When you finally select a site, you begin the exhausting process of egg laying. Each egg must be carefully positioned and attached to the substrate with a strong, flexible tether. The eggs themselves are works of biological engineering, transparent capsules that protect the developing embryos while allowing gas exchange and waste removal. You lay hundreds of eggs over several days, each one representing a significant investment of energy and resources. As you work, you become increasingly protective of the site, aggressively driving away any potential threats. Your maternal instincts, dormant throughout your life until now, emerge with surprising intensity. But here's where your story takes a tragic turn that's written into your very biology. Unlike many species, squid don't survive long after reproduction. The same hormonal changes that drive you to mate and reproduce also begin shutting down your other bodily systems. You're programmed for death, and there's nothing you can do to stop it. If you're male, the decline begins almost immediately after mating. Your appetite disappears, your hunting skills deteriorate, and your once vibrant colors fade to dull, mottled patterns. You become increasingly lethargic, spending more time hiding in crevices and less time actively moving through your territory. Other creatures in your ecosystem begin to notice your weakness. Predators that once gave you a wide berth now see you as an easy target. Scavengers start following you, waiting for the inevitable. Your reign as a successful hunter and territorial defender is coming to an end. If you're female, you have a bit more time, but your fate is equally sealed. After laying your eggs, you enter a period of intense maternal care that will consume the last of your life energy. You position yourself near your egg mass, using your remaining strength to guard them against the constant stream of predators that see them as an easy meal. You stop hunting for yourself entirely, dedicating all your attention to protecting your offspring. Fish, crabs, other squid, and countless other creatures are attracted to the rich protein source your eggs represent. You drive them away with the last reserves of your strength, your color patterns still capable of intimidating threats even as your body grows weaker. This is perhaps the most remarkable period of your entire life. Despite your declining physical condition, your intelligence remains sharp. You develop increasingly sophisticated strategies for protecting your eggs with minimal energy expenditure. You learn to position yourself where your presence alone deters most threats, saving your strength for the most serious challenges. Days pass, then weeks. Your body continues to deteriorate as you refuse to leave your post. Your skin loses its ability to change colors effectively. Your movements become slow and labored, but still you remain a dedicated guardian whose sole purpose is ensuring the next generation's survival. The eggs you're protecting are developing rapidly. Inside their transparent capsules, tiny squid are forming, your genetic legacy taking shape. They're going through the same developmental process you experienced months ago, their tentacles growing, their eyes forming, their brains developing the intelligence that will serve them throughout their own brief but remarkable lives. As your strength finally fails, you can see them moving inside their capsules, nearly ready to hatch. Your mission is almost complete. You've successfully transferred your genes to the next generation and given them the best possible start in life through your sacrifice. This is the cycle that has continued for millions of years, each generation living fast, reproducing once, and dying to make room for their offspring. It seems tragic from a human perspective, but it's actually an incredibly successful evolutionary strategy that has allowed squid to thrive in oceans around the world. Your death is not meaningless or wasteful. It's the final act of a life lived with remarkable intensity and purpose. From your first moments as a tiny transparent hatchling to your final hours as a devoted guardian, every day has been filled with challenges that tested your intelligence, your adaptability, and your survival skills to their limits. The ocean that claimed you will soon welcome your offspring, each one carrying a combination of your genes and your mate's genes into an uncertain but possibility-filled future. They'll face the same challenges you did, develop the same remarkable abilities, and ultimately make the same sacrifice to ensure the continuation of their species. But before we reach that final moment, there's still more to your story. The period between successful reproduction and death isn't just about decline and sacrifice. It's also about the culmination of everything you've learned and experienced throughout your extraordinary life. Your final weeks are a strange mixture of decline and clarity. While your body grows weaker, your mind remains remarkably sharp, perhaps sharper than it's ever been. The urgency of protecting your eggs has stripped away all distractions, leaving you with a laser focus that would be impressive if it weren't so heartbreaking to witness. You've become a master of efficiency, conserving every ounce of energy for the moments that matter most. When a small fish approaches your egg mass, you don't waste energy on dramatic color displays or aggressive posturing. Instead, you make minimal movements, a slight shift in position, a brief flash of warning coloration that communicate your intent with crystal clarity. Most threats get the message and move on, recognizing that even a dying squid protecting its young is not to be underestimated. But some predators are persistent or desperate enough to test your resolve. A large crab scuttles along the seafloor, its claws clicking against the rocks as it searches for an easy meal. It's noticed your eggs, and the protein they represent is too tempting to ignore. The crab approaches cautiously, aware that you're still alive, but calculating that your weakened state makes the risk acceptable. You let it get closer than you normally would, waiting until it's committed to its approach before responding. When you finally move, it's with the accumulated wisdom of months of hunting experience compressed into a single, perfectly timed strike. Your tentacles, though weaker than they once were, still know exactly where to grab. Your suckers still know how to lock onto a struggling target. Your beak still knows where to bite for maximum effect. The crab's shell cracks under the pressure, and it goes limp in your grasp. You don't eat it, food no longer interests you, but you position the body where other potential threats can see it. It's a message written in the universal language of predator and prey. These eggs are defended, and the cost of approaching them is higher than you might think. This kind of strategic thinking represents the peak of your intellectual development. You're not just reacting to immediate threats anymore. You're anticipating them, preparing for them, using psychological warfare to multiply the effectiveness of your diminishing physical capabilities. It's a level of sophistication that would impress researchers studying animal intelligence, if any were around to witness it. Your maternal instincts have also evolved beyond simple aggression. You've learned to read the subtle signs that indicate which threats are serious and which are merely opportunistic. A fish swimming past might glance at your eggs but show no signs of slowing down. You let it pass without interference. Another fish of the same species might approach with the purposeful movement of a hunter, that one gets the full defensive treatment. You've also developed an almost supernatural awareness of your eggs' development. You can sense when they're ready to hatch, even though the changes are invisible to most observers. Something about the way they move within their capsules, or perhaps chemical signals they're releasing, tells you that your vigil is nearly over. The first hatchling emerges on a day when the current is particularly strong, carrying fresh oxygen and nutrients through your territory. You watch as the tiny capsule splits and a miniature version of yourself pushes through, its tentacles already working with the same instinctive precision you remember from your own birth. It's barely the size of your smallest sucker, translucent and fragile, but it's unmistakably alive and aware. For a moment, it hovers near the empty capsule as if unsure what to do next. Then instinct kicks in, and it begins the same upward journey you made months ago, rising through the water column to join the plankton community where it will spend its first vulnerable weeks. More hatchlings follow over the next few hours. Each emergence is slightly different. Some break free quickly and decisively. Others struggle with their capsules for several minutes before finally pushing through. You don't intervene. This is their first test, and the ones who can't manage it on their own probably wouldn't survive the challenges ahead anyway. As you watch your offspring disperse into the vast ocean, you feel something that might be satisfaction. It's hard to interpret the emotions of a dying squid, but there's a sense of completion, of a job well done. Your genes are now swimming free in the water column, carrying forward the intelligence, the adaptability, and the survival instincts that allowed you to thrive in one of Earth's most challenging environments. Your body is shutting down now, systems failing one by one as the biological program that drove you to reproduce runs its final subroutines. Your color-changing abilities fade first. Your skin takes on a pale, mottled appearance that no longer responds to your attempts at camouflage. Your tentacles grow sluggish, your movements uncoordinated, but your eyes remain sharp almost to the end, tracking the movements of your newly hatched offspring as they drift away on the current. Some will be eaten within hours. That's the harsh reality of life in the plankton. Others will survive to grow, to hunt, to claim territories of their own. A few might even live long enough to reproduce, passing your genetic legacy forward to yet another generation. The ocean around your egg-laying site continues its eternal rhythms, indifferent to your personal drama. Fish swim past in their endless search for food. Currents shift and swirl, carrying nutrients and waste in the great cycles that sustain marine life. The sun's rays filter down from above, growing dimmer as they penetrate deeper into your underwater world. Your death, when it finally comes, is quiet and unremarkable. There's no struggle, no final dramatic moment. Your nervous system simply stops functioning, your muscles relax for the last time, and your body settles onto the seafloor where it will quickly become food for the scavengers that patrol these depths. Within days, crabs and other bottom dwellers will have recycled your tissues back into the ecosystem. The calcium from your gladius, the internal shell that gave your body structure, will dissolve and eventually be incorporated into the shells and skeletons of other creatures. Even in death, you're contributing to the continuation of life in your underwater community. But your real legacy isn't the nutrients your body provides to scavengers. It's the hundreds of tiny squid now swimming through the ocean's upper layers, each one carrying a unique combination of genetic material that represents millions of years of evolutionary refinement. They have your intelligence, your problem-solving abilities, your capacity for learning and adaptation. Some of them will discover new hunting techniques that you never mastered. Others will explore territories you never saw, adapting to environments and challenges that never tested your own survival skills. A few might even develop innovations, new ways of communicating, new solutions to predator problems, new strategies for finding mates that will spread through the squid population and influence the evolution of future generations. This is how your species has survived and thrived for so long. Each individual lives intensely but briefly, packing a lifetime of learning and adaptation into a single year. Then they reproduce once and die, making room for their offspring while ensuring that successful genetic combinations continue forward and unsuccessful ones are eliminated from the gene pool. It's a brutal but efficient system that has produced some of the ocean's most intelligent and adaptable creatures. Your brief life was part of an unbroken chain stretching back hundreds of millions of years, connecting you to ancestors who survived mass extinctions, ice ages, and countless other catastrophes that wiped out less adaptable species. The ocean you lived in was shaped by the presence of squid like you. Your hunting pressure influenced the behavior of fish populations. Your territorial disputes affected the distribution of resources among competing predators. Your intelligence contributed to an evolutionary arms race that has made marine ecosystems more complex and sophisticated over time. Even now, as your offspring begin their own journeys through the plankton, they're already influencing their environment. Their feeding will affect copepod populations. Their growth will provide food for larger predators. Their survival or death will determine which genetic combinations get passed forward to the next generation. Your story represents just one thread in an incredibly complex web of relationships that connects every creature in your ecosystem. The fish you hunted, the predators you avoided, the territory you defended, the mate you chose, all of these interactions rippled outward, affecting other creatures in ways both obvious and subtle. The crab that tried to eat your eggs learned something from the encounter, even if it didn't survive the experience. Other crabs in the area might have witnessed the confrontation and adjusted their own behavior accordingly. Fish that saw you hunting developed new awareness of the threats squid represent. Predators that successfully hunted squid like you refined their techniques and passed that knowledge onto their own offspring. This constant process of action and reaction, predator and prey, success and failure, drives the evolution of intelligence and adaptation throughout the marine world. Your life was both insignificant, one small squid among billions, and incredibly important as a crucial component in the vast interconnected system that is ocean life. The timing of your death was perfect in its own way. You lived just long enough to ensure your offspring had the best possible start, but not so long that you competed with them for resources or territory. Your generation is now making way for theirs, just as your parents' generation made way for yours. This turnover of generations happens with clockwork precision throughout the ocean. While your offspring are beginning their lives in the plankton, other adult squid are reaching the ends of their own reproductive cycles. The constant renewal ensures that squid populations remain genetically diverse and adaptable, capable of responding to environmental changes and new challenges. Your particular genetic combination will never exist again. Each squid represents a unique experiment in survival and adaptation, but the successful elements of your genetic makeup will persist, incorporated into your offspring and mixed with new combinations that might prove even more successful in the environments they'll face. The intelligence that allowed you to solve problems, recognize patterns, and adapt to new situations isn't unique to you, but your specific way of applying that intelligence was yours alone. Some of your offspring inherited your particular strengths, while others got different combinations of traits from both parents. This genetic lottery ensures that each new generation has the diversity needed to handle whatever challenges the ocean might present. As your story ends, theirs begin. They're facing the same fundamental challenges you once faced: finding food, avoiding predators, growing strong enough to claim territory, and eventually reproduce. But they're doing it in a slightly different ocean than the one you knew, with different predator pressures, different food sources, different opportunities and threats. Their success or failure will depend partly on the genes you passed on to them, but also on their ability to learn, adapt, and innovate in response to their specific circumstances. They carry your legacy forward, but they're not bound by your limitations. Each of them has the potential to exceed your achievements, to discover solutions you never found, to thrive in ways you never could. This is the ultimate measure of a successful life in the natural world, not how long you lived or how much you accomplished as an individual, but how effectively you contributed to the continuation and improvement of your species. By that measure, your life was a remarkable success, even though it lasted less than a year and ended in what might seem like tragic sacrifice. The ocean is vast and full of dangers, but it's also full of opportunities for creatures intelligent and adaptable enough to seize them. Your offspring are now part of that eternal struggle, carrying forward the lessons embedded in their genes while discovering new ones through their own experiences. Life as a squid might seem rough compared to creatures that live for decades or centuries, but there's something remarkable about packing so much intelligence, so much learning, so much adaptation into such a brief span. Every day matters when you only have a few hundred of them. Every decision carries weight when there's no time for lengthy deliberation. Your descendants will face challenges you never imagined in an ocean that continues to change and evolve, but they'll meet those challenges with the same intelligence and adaptability that served you so well, refined and improved by millions of years of evolutionary pressure. The cycle continues, as it has for countless generations before you and will for countless generations after your offspring. Each squid lives fast, learns quickly, reproduces once, and makes way for the next generation. It's a pattern that has proven remarkably successful, producing some of the most intelligent and adaptable creatures in the ocean. But there's another animal out there that has it way worse. Trust me, it's wild. Check out the video and see for yourself. Your final moments arrive not with drama or fanfare, but with a quiet settling into the rhythm of the ocean floor. Your body, once capable of lightning-fast color, changes and explosive jet propulsion, now rests motionless among the rocks where you made your last stand. The hundreds of eggs you guarded so fiercely have released their precious cargo into the vast blue above, and your biological purpose is complete. But death in the ocean is never truly an ending. It's a transformation. Within hours of your passing, the scavengers arrive. They've been waiting, watching from a respectful distance, while you were still capable of defending yourself. Now they move in with the efficiency of a cleanup crew that's perfected their routine over millions of years. A hermit crab scuttles over first, its borrowed shell clicking against the rocks as it investigates this unexpected windfall. Your soft tissues, rich with proteins and nutrients, represent a feast for creatures that spend most of their time scrounging for scraps. The crab tears away small pieces with its claws, methodically processing your remains into the basic building blocks that will fuel its own survival. Other scavengers follow, small fish that dart in to grab mouthfuls before retreating to safety, marine worms that emerge from the sediment to claim their share, bacteria that begin the microscopic work of breaking down complex molecules into simpler compounds. Each creature takes what it needs, and what they can't use gets passed down the chain to smaller and smaller organisms. Your gladius, the internal shell that gave structure to your boneless body, will take longer to disappear. Made of chitin and calcium carbonate, it's tougher than your soft tissues and will persist for weeks or months before finally dissolving into the seawater. Even then, its components don't vanish. They become part of the chemical soup that nourishes countless other forms of life. The calcium will be absorbed by growing corals, incorporated into the shells of mollusks, used by countless creatures to build the hard structures they need for protection and support. The chitin will feed bacteria and fungi, which will in turn feed larger organisms, each transfer of nutrients supporting the vast web of interdependence that keeps the ocean ecosystem functioning. Meanwhile, far above in the sunlit waters of the plankton community, your offspring are beginning their own struggles for survival. They're scattered across miles of ocean now, each one a tiny speck of translucent life drifting with the currents. Most will never make it past their first week. That's the brutal mathematics of marine reproduction, where success is measured not by individual survival, but by the handful that manage to beat impossible odds. The ones that do survive are already demonstrating the intelligence you passed on to them. They're learning to recognize the subtle movements that indicate prey, developing the timing and coordination needed for successful hunting, figuring out how to use their rudimentary color-changing abilities to avoid predators. Each small success builds their confidence and skills, preparing them for the challenges ahead. Some of your offspring will discover abilities you never developed. The ocean is vast and full of ecological niches that reward different survival strategies. One might become exceptionally good at deep water hunting, developing enhanced sensitivity to the bioluminescent signals that many deep-sea creatures use for communication. Another might specialize in shallow water environments, mastering the complex interplay of light and shadow that characterizes coral reef ecosystems. A few might even develop innovations that spread through the broader squid population. Every generation produces individuals that push the boundaries of what their species can accomplish, finding new solutions to old problems or discovering entirely new ways of exploiting environmental opportunities. These innovations don't happen through conscious invention. They emerge from the constant pressure of natural selection, acting on countless small variations in behavior and ability. Your genetic contribution to this ongoing experiment in survival is now dispersed among hundreds of individuals, each one testing different combinations of traits in different environments. Some will prove highly successful, reproducing early and often. Others will struggle, their particular mix of characteristics proving less well-suited to the challenges they face. This is how evolution works at the most fundamental level, not through grand design or purposeful improvement, but through the accumulation of countless small advantages and disadvantages played out over generations. Your life was one data point in a massive experiment that's been running for hundreds of millions of years, testing different ways of being a successful predator in marine environments. The intelligence that made you such an effective hunter didn't emerge overnight. It's the product of evolutionary pressures that have been shaping cephalopod brains for eons, selecting for individuals capable of solving increasingly complex problems. Each generation had to be smarter than the last to survive in an ocean full of other intelligent predators and increasingly sophisticated prey. Your ability to change color and texture at will represents millions of years of refinement in biological engineering. The chromatophores in your skin, the neural pathways that controlled them, the behavioral programs that determined when and how to use them. All of these systems had to evolve together, each component useless without the others. The same is true for your jet propulsion system, your sophisticated eyes, your problem-solving abilities, your complex mating behaviors. Every aspect of your biology represents a solution to specific environmental challenges, tested and refined through countless generations of trial and error. Now your offspring carry these solutions forward into a world that's constantly changing. Ocean temperatures fluctuate, prey species evolve new defenses, predators develop new hunting strategies, chemical compositions shift with currents and seasons. The squid that survive are those whose inherited traits happen to match the demands of their particular time and place. But survival isn't just about inherited traits. It's also about learning and adaptation during an individual's lifetime. Your offspring will face challenges you never encountered, and their success will depend partly on their ability to learn from experience and adjust their behavior accordingly. This combination of inherited capability and individual learning is what makes cephalopods so remarkably adaptable. They don't just rely on fixed behavioral programs encoded in their genes. They can modify their responses based on what works in their specific circumstances. A young squid that finds itself in an environment with unusual predators will learn to recognize and avoid those threats, even if its parents never encountered them. The intelligence that allowed you to solve novel problems, recognize individual fish, and develop sophisticated hunting strategies is now being tested in new environments by your descendants. Some will prove even more capable than you were, pushing the boundaries of what squid intelligence can accomplish. Others will struggle with challenges that you handled easily, their particular combination of traits proving less well-suited to their circumstances. This variation is crucial for the long-term survival of your species. In a stable environment, the optimal strategy might be to produce offspring identical to yourself, perfect copies of a proven success. But the ocean is anything but stable, and the challenges facing your offspring will be different from those you faced. Climate change is altering ocean chemistry and temperature. Human activities are introducing new pollutants and changing food webs. Other species are evolving new capabilities that shift the balance of predator-prey relationships. In such a dynamic environment, diversity is essential. The more different your offspring are from each other, the more likely it is that some of them will happen to have the traits needed for success. So, your life played a crucial role in generating this diversity. The mate you chose contributed genes that complemented your own, creating combinations that had never existed before. The timing of your reproduction, the location where you laid your eggs, the care you provided during their development. All of these factors influenced which offspring survived and what traits they carried forward. Even your death served a purpose beyond clearing ecological space for the next generation. The nutrients from your body are now part of the food web that will sustain your offspring as they grow. The carbon in your tissues will cycle through the ecosystem, perhaps ending up in the bodies of creatures your descendants will hunt, creating connections across space and time that link your life to theirs. The location where you died will also play a role in the ongoing story of your ecosystem. Your remains have added organic matter to the seafloor, enriching the sediment and supporting the growth of bacteria and other microorganisms that form the base of the food web. Small changes in nutrient distribution can have cascading effects throughout the system, influencing everything from plankton blooms to fish migration patterns. These effects are subtle and indirect, but they're part of the complex web of interactions that shapes marine ecosystems. Every organism, no matter how small or short-lived, contributes to the overall functioning of the system. Your life and death were part of a vast collaborative effort involving countless species, each one playing its role in maintaining the delicate balance that allows ocean life to flourish. The territory you once defended so fiercely has already been claimed by another squid, probably one of your own offspring, grown large enough to establish its own hunting grounds. The cycle of territorial competition, successful defense, and eventual replacement continues, ensuring that the best available habitat is always occupied by the most capable individuals. Your hunting techniques, refined through months of trial and error, are being rediscovered by your descendants as they face the same challenges you once confronted. Some will develop the same solutions you did: the patient ambush, the precisely timed strike, the strategic use of terrain. Others will find different approaches, perhaps more effective ones, that represent genuine innovations in squid hunting strategy. The predators you learned to avoid are still there, still posing the same threats to your offspring that they once posed to you. But they're also still being challenged by new generations of increasingly intelligent squid, creating an ongoing evolutionary arms race that pushes both predator and prey toward greater sophistication. This dynamic tension between competing species is one of the driving forces behind the evolution of intelligence in marine ecosystems. Predators must become smarter to catch increasingly clever prey. Prey must become more cunning to avoid increasingly sophisticated predators. Each improvement on one side creates pressure for improvement on the other, leading to a gradual increase in cognitive capabilities across the entire system. Your contribution to this process was small but real. The intelligence you demonstrated, the problems you solved, the innovations you developed, all of these represent tiny steps forward in the ongoing evolution of cephalopod cognition. Your offspring will build on your achievements, developing capabilities that exceed your own, just as you exceeded the capabilities of your parents. The ocean you lived in was shaped by millions of years of such incremental improvements, each generation slightly more capable than the last. The complex ecosystems we see today are the result of countless individual stories, like yours. Brief lives lived with intensity and intelligence, each one contributing to the slow but relentless advance of biological sophistication. Your species' strategy of living fast and reproducing once might seem wasteful compared to creatures that live for decades and reproduce repeatedly, but it's actually an incredibly efficient way of testing and refining genetic combinations. Each generation represents a new experiment in survival, with successful innovations quickly spreading through the population while unsuccessful ones are eliminated. This rapid turnover of generations allows squid populations to adapt quickly to changing conditions. When environmental pressures shift, the genetic variations that prove most successful become more common in the next generation. Over just a few reproductive cycles, entire populations can evolve new capabilities or behavioral strategies. The intelligence that made you such an effective predator is now being tested in environments around the world, as your distant relatives face different challenges in different oceans. Arctic squid must cope with extreme cold and seasonal variations in food availability. Tropical squid navigate complex coral reef ecosystems with different predator-prey relationships. Deep-sea squid hunt in perpetual darkness, using senses you never needed. Each population faces its own unique set of challenges, and each develops its own solutions. The basic template of squid intelligence, the ability to learn, adapt, and solve problems, remains constant, but its expression varies depending on local conditions. This flexibility is what has allowed cephalopods to colonize virtually every marine environment on Earth. Your life story, brief as it was, represents one variation on the theme of intelligent adaptation to marine challenges. Your offspring will write their own stories, facing new obstacles and discovering new solutions. Some will succeed beyond your wildest capabilities. Others will fail despite possessing all the tools for success. This mixture of success and failure, innovation and tradition, individual achievement and species-level progress is what drives the ongoing evolution of life in the ocean. Your contribution was small but essential. One more test of what it means to be an intelligent predator in a challenging environment. The legacy you left behind isn't just genetic, it's also behavioral and ecological. The hunting grounds you established, the predator-prey relationships you influenced, the territorial boundaries you defended, all of these have ongoing effects that will persist long after your physical remains have been recycled into the ecosystem. Future generations of squid will benefit from the knowledge you helped create about which strategies work and which don't, which environments are most productive, which predators pose the greatest threats. This information isn't passed down through conscious teaching. It's embedded in the behavioral patterns and habitat preferences that successful squid tend to develop. The ocean continues its eternal cycles, indifferent to individual dramas, but somehow incorporating them all into the larger story of life on Earth. Currents flow, tides rise and fall, seasons change, and through it all, new generations of squid emerge to test their intelligence against the challenges of marine existence. Your brief time in this vast system was meaningful not because it lasted long, but because it was lived with such intensity and purpose. Every day brought new challenges that tested your capabilities to their limits. Every decision carried real consequences that could mean the difference between life and death. This is what it means to live as a squid, to compress a lifetime of learning, growth, and achievement into a single year of incredible intensity. Your story may be over, but the intelligence and adaptability you represented live on in your offspring, ready to face whatever challenges the ocean might present. The water above your resting place continues to teem with life, each creature playing its part in the ongoing story of marine evolution. Your descendants swim among them, carrying forward the lessons written in their genes while discovering new ones through their own experiences. Life as a squid might be brief, but it's anything but simple. The complexity of behaviors, the sophistication of problem-solving abilities, the intricate social interactions, all of these rival or exceed what we see in creatures that live much longer. Your species has proven that intelligence and adaptability don't require longevity, that a year lived with full awareness and capability can accomplish more than decades of mere existence. But there's another animal out there that faces even greater challenges, lives an even more intense existence, and has developed survival strategies that make your remarkable abilities look almost mundane by comparison. Trust me, it's absolutely incredible. Check out the video and see for yourself. The ocean floor where you spent your final moments protecting your offspring has become a small ecosystem in itself. Crabs scuttle between the rocks where you once hid, fish swim through the water column you once dominated, and new squid explore the territory you fought so hard to claim. Your physical presence is gone, but the effects of your life ripple outward through the marine community in ways both obvious and subtle. The nutrients from your body have enriched the local environment, supporting the growth of bacteria and algae that form the foundation of the food web. These microscopic organisms multiply rapidly, their increased numbers supporting larger creatures that in turn feed the fish and crustaceans your descendants will eventually hunt. Even in death, you're contributing to the survival of your genetic legacy, but your offspring face a world that's both familiar and alien compared to the one you knew. The basic challenges remain the same: find food, avoid predators, grow strong enough to claim territory, and reproduce. But the specifics are constantly changing. Ocean temperatures fluctuate with seasonal patterns and longer climate cycles. Predator populations rise and fall based on their own reproductive success and food availability. New species invade established territories, while others disappear entirely. Your descendants must navigate these shifting conditions with the same intelligence and adaptability you once relied on, but they're doing it in circumstances you never faced. Some find themselves in waters warmer than anything you experienced, where different prey species thrive and unfamiliar predators hunt. Others encounter colder currents that bring new opportunities and challenges. The intelligence you passed on to them proves remarkably flexible in meeting these varied demands. A young squid, finding itself in an environment dominated by fast-moving schooling fish, develops hunting strategies optimized for intercepting multiple small targets rather than ambushing larger individual prey. Another, living near rocky reefs with complex three-dimensional structure, becomes expert at using terrain to its advantage in ways you never needed to master. This adaptability extends beyond hunting techniques to every aspect of their lives. Territorial behaviors that worked perfectly in your deep water habitat might be completely inappropriate in shallow coastal waters where different rules apply. Mating displays that impressed partners in your generation might fail entirely with squid that have developed different aesthetic preferences or communication styles. Your offspring don't just inherit your capabilities, they build on them, refine them, sometimes surpass them entirely. And one might develop color-changing abilities more sophisticated than yours, capable of producing patterns so complex they constitute an entirely new form of communication. Another might discover hunting techniques that combine stealth and speed in ways you never attempted. These innovations don't happen through conscious invention. They emerge from the constant pressure of survival, acting on countless small variations in behavior and ability. A squid that happens to be slightly better at coordinating its tentacles gains a small advantage in hunting success. One with marginally better pattern recognition avoids predators more effectively. Over time, these tiny advantages accumulate into significant differences in survival and reproductive success. The most successful innovations spread through the population, not through teaching or imitation, but through the simple fact that squid with advantageous traits tend to produce more offspring. Their genetic combinations become more common in each subsequent generation, while less successful variations gradually disappear. This process of natural selection operates continuously, but it's not always predictable. Traits that provide advantages in one environment might be neutral or even harmful in another. A hunting strategy that works perfectly during times of abundant prey might fail catastrophically when food becomes scarce. The intelligence that makes squid so adaptable also makes their evolutionary path highly dependent on specific circumstances. Your descendants are now testing thousands of different combinations of traits in hundreds of different environments. Most will prove average, good enough for survival, but not exceptional. Some will be spectacular failures, unable to cope with the demands of their particular circumstances. But a few will represent genuine breakthroughs, discovering new ways of being successful that open up previously unexploited opportunities. These breakthrough individuals don't just survive and reproduce, they transform the environments they inhabit. A squid that discovers a new hunting technique might shift predator-prey relationships throughout its ecosystem. One that develops novel social behaviors might change the way squid interact with each other across entire regions. The cumulative effect of countless individual innovations over millions of generations has produced the remarkable diversity of cephalopod species we see today. From tiny deep-sea squid that hunt in perpetual darkness to massive surface-dwelling species that engage in complex social behaviors, each represents a different solution to the challenge of being an intelligent predator in marine environments. Your genetic contribution is now part of this ongoing experiment, scattered among hundreds of offspring that are themselves beginning to reproduce. Some of your grandchildren will carry forward the most successful elements of your genetic legacy while discarding less effective traits. Others will represent entirely new combinations that have never been tested before. The mathematical beauty of this system is that it automatically optimizes for success without requiring any central planning or conscious direction. Each individual squid is essentially running its own experiment in survival, and the results of millions of these experiments get combined and recombined in each new generation. But success in this system isn't measured by individual achievement. It's measured by contribution to the ongoing survival and evolution of the species. A squid that lives for 2 years instead of 1 might seem more successful from a human perspective, but if it fails to reproduce effectively, its genetic line ends there. Meanwhile, a squid that lives only 8 months but produces hundreds of viable offspring has achieved evolutionary success regardless of its brief lifespan. Your own life exemplifies this principle perfectly. You lived less than a year, but you packed that brief span with remarkable achievements. You survived the vulnerable juvenile period when most of your siblings perished. You successfully claimed and defended the territory against competitors. You mastered complex hunting techniques that allowed you to thrive in a challenging environment. Most importantly, you found a suitable mate and produced hundreds of offspring before making the ultimate sacrifice to ensure their survival. By any measure that matters in evolutionary terms, your life was a spectacular success. The intelligence and adaptability you demonstrated are now dispersed among your descendants, being tested and refined in new environments and circumstances. Some will prove even more capable than you were, pushing the boundaries of what squid can accomplish. The territory you once called home has been claimed by one of these descendants, probably carrying genes that contributed to your own success. The cycle of territorial establishment, successful defense, and eventual replacement continues, ensuring that prime habitat remains occupied by the most capable individuals in each generation. Your hunting grounds still teem with the same types of prey you once stalked, but they're now being pursued by squid that might employ subtly different techniques. Evolution is a conservative process. Successful strategies tend to persist across generations, but it's also constantly experimenting with variations that might prove even more effective. The predators you learned to avoid are still there, still posing threats to your offspring, but they're also facing new challenges as each generation of squid becomes slightly more sophisticated in its evasion techniques. This creates an ongoing arms race where both predator and prey must continuously improve their capabilities just to maintain their current level of success. Your contribution to this evolutionary arms race was small but real. Every successful evasion, every clever hunting strategy, every innovative use of camouflage added to the accumulated knowledge base that informs squid behavior. Your descendants don't consciously learn from your experiences, but they inherit the genetic foundations that made those experiences possible. The ocean you inhabited was shaped by millions of years of such incremental improvements, each generation building slightly on the achievements of the previous one. The complex behaviors and sophisticated intelligence we observe in modern cephalopods are the cumulative result of countless individual stories, like yours. Brief lives lived with remarkable intensity and purpose. Your species' strategy of rapid reproduction and short lifespans might seem wasteful, but it's actually incredibly efficient for testing and propagating successful innovations. Each generation represents a massive parallel experiment, with thousands of individuals simultaneously testing different approaches to survival challenges. The results of these experiments get incorporated into the gene pool within a single reproductive cycle. Successful innovations can spread through entire populations in just a few generations, while unsuccessful variants are quickly eliminated. This rapid evolutionary response allows squid populations to adapt quickly to changing environmental conditions. Climate change, pollution, overfishing, and other human impacts are creating new selective pressures that your descendants must navigate. The genetic diversity you helped create by choosing your particular mate and producing your unique offspring gives the species flexibility to respond to these challenges. Some of your descendants will prove particularly well adapted to warmer water temperatures. Others might be more tolerant of chemical pollutants or better able to exploit new food sources created by ecosystem disruptions. This variation ensures that squid populations can persist even as environmental conditions change rapidly. The intelligence that characterized your species long before humans appeared on the scene now faces the ultimate test: adaptation to a world increasingly dominated by human activities. Ocean chemistry is changing, food webs are being disrupted, and new types of pollution create hazards that no squid has ever encountered before. But intelligence and adaptability are precisely the traits that will determine which species survive these unprecedented challenges. Your descendants enter this transformed world carrying genetic combinations that have been tested and refined over hundreds of millions of years, equipped with problem-solving abilities that rival those of much larger-brained creatures. They face the future not as passive victims of environmental change, but as active participants in the ongoing evolution of marine ecosystems. Their responses to new challenges will help determine not just their own survival, but the fate of countless other species that depend on healthy ocean ecosystems. The brief story of your individual life has become part of a much larger narrative, the ongoing saga of intelligence and adaptation in Earth's oceans. Your genetic legacy swims forward into an uncertain but possibility-rich future, carrying the accumulated wisdom of millions of years of evolutionary experimentation. The water column where you once hunted continues to support new generations of predators and prey, each playing their role in the complex web of relationships that sustains marine life. Your offspring move through this three-dimensional world with the same grace and intelligence you once demonstrated, facing challenges both familiar and unprecedented. Some will achieve things you never could have imagined. Others will struggle with problems that you solved easily. All will contribute to the ongoing experiment in cephalopod intelligence, testing new combinations of traits and behaviors against the relentless demands of ocean survival. The cycle continues, as it has for countless generations and will for countless more. Each squid lives intensely, learns rapidly, reproduces once, and makes way for the next wave of evolutionary experimentation. It's a pattern that has proven remarkably successful, producing some of the ocean's most intelligent and adaptable creatures. Your descendants carry forward not just your genes, but the entire accumulated heritage of cephalopod evolution. Hundreds of millions of years of successful adaptation compressed into genetic codes that guide development, behavior, and survival strategies. They represent the cutting edge of an evolutionary process that continues to produce new solutions to the ancient challenge of thriving in marine environments. The intelligence that made you such a formidable predator is now distributed among hundreds of individuals, each one a unique experiment in the application of cephalopod cognitive abilities. Some will discover capabilities that you never developed. Others will perfect techniques that you only began to master. All will face the fundamental challenge that has driven cephalopod evolution from the beginning: how to be a successful predator in an environment full of other intelligent creatures, all competing for the same resources while avoiding becoming someone else's meal. The solutions they discover will be tested against the harsh realities of ocean survival and either validated through reproductive success or eliminated through natural selection. This is the essence of what it means to be a squid, to participate in an ongoing experiment in intelligence and adaptation that spans geological timescales while living each individual moment with complete focus and intensity. Your brief year of existence was both insignificant in the cosmic scheme and absolutely crucial to the continuation of one of evolution's most remarkable success stories. The ocean stretches endlessly in all directions, full of mysteries yet to be discovered and challenges yet to be overcome. Your offspring swim through this vast realm, carrying the genetic legacy of your remarkable species, ready to write their own chapters in the ongoing story of cephalopod intelligence and adaptability. But there's another creature in these same waters that faces even more extreme challenges, lives in existence so intense it makes your remarkable story seem almost peaceful by comparison. The survival strategies this animal has developed are so extraordinary, so perfectly adapted to its harsh environment, that they push the very limits of what we thought was biologically possible. Trust me, when you see what this creature goes through every single day just to stay alive, it will completely change how you think about survival in the natural world. Check out the video and see for yourself. The ocean that swallowed your remains is the same one that now hosts your offspring, but they're experiencing it in ways you never could have imagined. Your genetic legacy has scattered across thousands of square miles of open water, each descendant carrying forward pieces of your intelligence while developing their own unique approaches to survival. Some of your offspring have discovered hunting techniques that would have amazed you. One has learned to coordinate attacks with other young squid, something your solitary nature never allowed you to explore. They've figured out how to communicate through rapid color changes, creating a visual language that lets them hunt cooperatively. When they encounter a school of fish, they don't attack randomly like most juvenile squid. Instead, they position themselves strategically, each one taking a different angle, herding their prey into a killing zone where escape becomes impossible. This cooperative behavior isn't something they learned from you. It's an innovation that emerged from the specific circumstances they found themselves in. The waters they inhabit have different predator pressures than yours did, creating opportunities for group tactics that would have been suicidal in your territory. They've adapted to their environment in ways that push the boundaries of typical squid behavior. Another of your descendants has gone in the opposite direction, becoming even more solitary and specialized than you ever were. It's developed an almost supernatural ability to remain motionless for hours at a time, its metabolism slowing to near dormancy levels while it waits for prey. When something finally comes within range, its strike is so fast and precise that even high-speed cameras would struggle to capture the movement. This extreme patience represents a different solution to the same energy conservation challenges you faced. Where you relied on intelligence and adaptability, this offspring has pushed physical capabilities to their limits, becoming a living trap that's nearly impossible to detect or avoid. Its success rate is higher than yours ever was, but it also spends far more time between meals. The diversity of strategies your offspring have developed reflects the incredible plasticity of cephalopod intelligence. Each one faces slightly different environmental pressures, and their responses demonstrate just how many different ways there are to be a successful squid. Some have become speed specialists, others masters of camouflage. A few have developed social skills that border on the sophisticated, while others have retreated into complete isolation. But perhaps the most remarkable development involves one of your descendants that has ventured into territories no squid from your bloodline has ever explored. It's moved into the deep abyssal plains, where eternal darkness and crushing pressure create conditions that would have killed you instantly. Down there, the rules of survival are completely different, and this descendant has had to reinvent almost everything about how to be a squid. In the lightless depths, visual camouflage becomes meaningless. Instead, this descendant has developed enhanced sensitivity to electrical fields, allowing it to detect prey and predators through the minute bioelectrical signatures all living things produce. It's learned to navigate by reading the subtle patterns of current and chemical gradients that flow through the deep ocean like invisible highways. The prey down there is unlike anything you ever hunted. Strange creatures with their own bioluminescent signals, fish adapted to extreme pressure, invertebrates that exist nowhere else on Earth. Your descendant has had to develop entirely new hunting strategies, learning to interpret the alien light shows of deep-sea creatures and use them for navigation and prey detection. The pressure at those depths would have crushed your body instantly, but your descendant's physiology has adapted remarkably quickly. Its tissues are less dense, its gas-filled organs modified to function under extreme compression. It's become something that's still recognizably a squid, but adapted to conditions so extreme they might as well be on another planet. This ability to colonize radically different environments within a single generation demonstrates the incredible potential locked within cephalopod genetics. The same basic body plan that made you successful in moderate depths has proven capable of modification for survival in some of Earth's most extreme conditions. Meanwhile, other descendants have moved in the opposite direction, venturing into shallow coastal waters where sunlight penetrates and entirely different challenges await. Here, the abundance of light makes camouflage both more crucial and more difficult to achieve. These offspring have developed chromatophore control so precise they can mimic not just colors and patterns, but actual textures, becoming virtually indistinguishable from rocks, coral, or seaweed. One has become so skilled at mimicry that it's learned to imitate other animals entirely. When threatened, it doesn't just change color, it changes shape, behavior, and movement patterns to resemble everything from flatfish to sea snakes. This behavioral flexibility represents a level of cognitive sophistication that goes far beyond simple camouflage into active deception and role-playing. The shallow water descendants face predator pressures you never encountered. Seabirds diving from above, marine mammals with echolocation, fish with enhanced visual systems adapted to bright conditions. Each threat requires different evasion strategies, and your offspring have had to develop a toolkit of responses more diverse than anything you ever needed. Some have learned to use the complex three-dimensional structure of coral reefs to their advantage, becoming maze runners that can navigate through impossibly tight spaces, while larger predators struggle to follow. Others have mastered the art of using water surface tension, learning to position themselves just below the surface where diving predators lose visual contact at the crucial moment. The most successful of your shallow water descendants has discovered something remarkable: how to use human activity to its advantage. Fishing boats, piers, and other artificial structures create unique microenvironments with their own opportunities and challenges. This descendant has learned to hunt in the shadows of boats, using the noise and movement of human activity as cover for its own hunting. It's even learned to exploit the feeding behaviors of seabirds that follow fishing vessels. When birds dive for scraps thrown overboard, they create commotion that disorients small fish, making them easy targets for a patient squid. Your descendant has essentially learned to use other predators as beaters, driving prey into positions where it can strike effectively. This kind of opportunistic intelligence, the ability to recognize and exploit novel situations, represents one of the highest expressions of cephalopod cognitive ability. Your descendant isn't just adapting to its environment, it's actively manipulating it to create better hunting opportunities. But adaptation isn't always about finding new opportunities. Sometimes it's about surviving catastrophic changes that threaten entire ecosystems. One group of your descendants found themselves in waters affected by a major pollution event that killed many of the fish species they normally hunted. Faced with the choice between starvation and adaptation, they did something unprecedented. They changed their diet entirely. Instead of hunting fish, they began specializing in jellyfish and other gelatinous creatures that were largely unaffected by the pollution. This dietary shift required completely new hunting techniques, since jellyfish move differently than fish and have different defensive capabilities. Your descendants had to learn to avoid stinging tentacles while still securing adequate nutrition from prey with much lower protein content. The transition wasn't easy. Many didn't survive the learning process, unable to adapt quickly enough to the new food source. But those that succeeded developed techniques so effective, they continued hunting jellyfish even after fish populations began to recover. They discovered an underexploited resource and claimed it as their own niche. This dietary specialization had unexpected consequences. Jellyfish have different seasonal patterns than fish, forcing these descendants to modify their entire life cycle. Skills. They learned to time their reproduction to coincide with jellyfish blooms, ensuring their offspring would have abundant food during their most vulnerable early weeks. The genetic changes required for this kind of behavioral flexibility happened remarkably quickly, demonstrating just how responsive cephalopod evolution can be to environmental pressures. Within just a few generations, these descendants had become fundamentally different creatures, still squid, but squid adapted to a completely different ecological niche. Your contribution to this adaptive radiation was the genetic foundation that made such rapid change possible. The intelligence and behavioral flexibility you demonstrated in your own life provided the raw material that natural selection could work with to produce these remarkable variations. Each successful adaptation by your descendants represents a small victory against the constant pressure of environmental change. Climate shifts, pollution events, overfishing, and habitat destruction create ongoing challenges that require continuous adaptation. The genetic diversity you helped create by reproducing with your carefully chosen mate provides the variation needed for some offspring to survive whatever changes come next. But survival isn't just about individual adaptation. It's also about the complex web of relationships between species. Your descendants don't exist in isolation. They're part of ecosystems where every species affects every other species in ways both obvious and subtle. Changes in squid behavior ripple outward, affecting prey populations, predator relationships, and even the distribution of nutrients through marine food webs. One of your descendants has become so successful at hunting a particular type of small fish that it's actually affecting the fish's evolutionary trajectory. The constant predation pressure is selecting for faster, more evasive fish, which in turn creates pressure for your descendant to become an even more effective hunter. This kind of evolutionary arms race drives increasing sophistication in both predator and prey. The fish your descendant hunts have begun schooling in tighter formations and developing more complex escape behaviors. In response, your descendant has learned to anticipate these evasion patterns, positioning itself not where the fish are, but where they're likely to flee when threatened. It's become a student of fish psychology, predicting behavior patterns with remarkable accuracy. This kind of predictive hunting represents a level of cognitive sophistication that rivals what we see in much larger-brained predators. Your descendant isn't just reacting to stimuli, it's modeling the mental states of its prey, essentially developing a theory of mind that allows it to anticipate their responses to various situations. The success of this hunting strategy has allowed your descendant to claim territory in areas where other squid struggle to find adequate food. It's become a specialist in a way that you never were, focusing all its intelligence and capabilities on mastering a single type of prey rather than maintaining the generalist approach that served you well. This specialization represents both an opportunity and a risk. The specialist descendant is incredibly effective within its niche, but it's also vulnerable to changes that affect its preferred prey. If disease, climate change, or other factors reduce the population of fish it's adapted to hunt, it might struggle to survive, while more generalist squid adapt to alternative food sources. The balance between specialization and generalization is one of the fundamental trade-offs in evolutionary biology. Your various descendants are testing different points along this spectrum, and their success or failure will depend partly on how stable their environments remain over the coming years. Some have remained generalists like you were, maintaining the flexibility to hunt various prey types and adapt to changing conditions. Others have become extreme specialists, developing capabilities that make them incredibly effective in specific circumstances, but potentially vulnerable to environmental changes. The most successful strategy depends entirely on what the future holds, and that's impossible to predict. The descendants that seem most successful today might be the ones that struggle tomorrow if conditions change dramatically. Conversely, individuals that seem to be barely surviving in current conditions might possess exactly the traits needed to thrive in future environments. This uncertainty is what makes genetic diversity so crucial for long-term survival. By producing offspring with varied capabilities and behavioral tendencies, you ensured that your genetic line would have representatives testing multiple strategies simultaneously. It's a biological hedge against an unpredictable future. Your descendants now swim through oceans that are changing faster than they have in millions of years. Ocean acidification is altering the chemistry of seawater, affecting everything from the formation of shells to the behavior of fish. Rising temperatures are shifting the distribution of prey species and changing current patterns that have been stable for millennia. These changes create both challenges and opportunities. Some of your descendants are discovering that warming waters have brought new prey species into their territories, opening up food sources that weren't available during your lifetime. Others are struggling as their traditional hunting grounds become too warm or too acidic to support the ecosystems they depend on. The most adaptable descendants are those that inherited your intelligence and behavioral flexibility. They're learning to read environmental cues that indicate where food is likely to be found under the new conditions, adjusting their hunting strategies and territorial boundaries as ecosystems shift around them. One remarkable descendant has learned to follow the movements of commercial fishing fleets, taking advantage of the disruption these operations create in fish populations. When trawl nets disturb the seafloor or purse seines concentrate fish into tight groups, this descendant positions itself to exploit the chaos, picking off disoriented or injured prey that would be difficult to catch under normal circumstances. This behavior requires not just intelligence, but also the ability to learn from human activity patterns, understanding when and where fishing operations are likely to occur, what types of disturbance they create, and how to exploit these situations safely. Your descendant has essentially learned to use industrial fishing as a tool for its own hunting success. The cognitive demands of this lifestyle are enormous. Your descendant must simultaneously track fishing vessel movements, monitor environmental conditions, assess predator threats, and identify hunting opportunities, all while avoiding the very real dangers posed by fishing gear and vessel traffic. It's operating in an environment that didn't exist during your lifetime, yet it's thriving by applying the same kinds of problem-solving abilities you once used in much simpler circumstances. This adaptability to human-altered environments represents one of the most impressive demonstrations of cephalopod intelligence in the modern ocean. Moose, your descendants aren't just passive victims of human activity, they're active participants in human-modified ecosystems, finding ways to exploit new opportunities while avoiding new dangers. But human influence isn't always something that can be adapted to or exploited. Plastic pollution creates hazards that no amount of intelligence can fully overcome. Microplastics in the water column interfere with feeding, while larger debris creates navigation hazards and potential traps. Some of your descendants have learned to recognize and avoid obvious plastic objects, but the microscopic particles are impossible to filter out completely. Chemical pollutants present even more insidious challenges. Compounds that didn't exist during your lifetime now accumulate in tissue and interfere with neural function, potentially undermining the very intelligence that makes cephalopods so successful. Your descendants must survive not just the traditional challenges of predation and competition, but also a cocktail of human-made toxins that their evolutionary history couldn't have prepared them for. Despite these challenges, cephalopod populations continue to thrive in many parts of the world, and some are actually expanding their ranges as climate change creates new opportunities. Your genetic legacy is part of this ongoing success story, contributing to a gene pool that's proving remarkably resilient in the face of unprecedented environmental change. The intelligence and adaptability that characterized your brief life have become even more valuable in a world where conditions change rapidly and unpredictably. Your descendants that inherited these traits most strongly are the ones most likely to navigate successfully through the challenges ahead. As your genetic legacy disperses through the world's oceans, it carries with it the accumulated wisdom of millions of years of cephalopod evolution. Each descendant represents a unique experiment in applying this ancient intelligence to modern challenges, testing new combinations of traits against environmental pressures that are both familiar and completely novel. The ocean that claimed your body continues to nurture your genetic legacy, providing the stage where your descendants will write their own chapters in the ongoing story of cephalopod evolution. Their successes and failures will determine which traits get passed forward to future generations and which evolutionary paths prove most promising in an uncertain world. Your brief year of existence has become part of something much larger, an ongoing experiment in intelligence and adaptation that spans geological timescales while playing out in individual lives measured in months rather than years or decades. Each descendant lives with the same intensity you once demonstrated, packing remarkable achievements into impossibly brief lifespans. The cycle continues, as it has for hundreds of millions of years, and will for countless generations to come. Each squid contributes its own small piece to the vast mosaic of cephalopod evolution, testing new possibilities while building on the accumulated successes of all who came before. Your descendants swim forward into an uncertain but opportunity-rich future, carrying the genetic legacy of one of evolution's most remarkable success stories. They face challenges you never encountered and opportunities you never imagined, but they meet them with the same intelligence and adaptability that made your own brief life such a remarkable achievement. The water that once supported your hunting grounds now flows through territories claimed by your genetic legacy, connecting your story to theirs across time and space. Your brief existence has become part of the eternal rhythm of life in Earth's oceans, where intelligence meets challenge and adaptation ensures survival in an ever-changing world. The ocean depths, where your final chapter played out, have become quiet, but the story continues in waters far above. Your genetic legacy has now dispersed across multiple generations, each one further removed from your original existence, yet still carrying the essential blueprint that made your intelligence possible. These great-grandchildren of yours face a world that would be unrecognizable to you, where the challenges have multiplied and the solutions require innovations you could never have imagined. Some have ventured into the twilight zone, that mysterious realm between the sunlit surface and the abyssal depths where bioluminescence becomes the primary language of survival. Here, your descendants have learned to speak in light, not just the simple color changes you once mastered, but complex patterns of bioluminescent communication that rival the most sophisticated visual displays on Earth. They've developed the ability to control specialized light-producing organs with the same precision you once used to manipulate chromatophores. Flashing patterns convey everything from territorial warnings to mating invitations, creating underwater light shows that would dazzle human observers if any were present to witness them. This evolution of communication represents a quantum leap beyond anything your generation achieved. The most remarkable aspect of these displays isn't their beauty, it's their efficiency. In the energy-poor environment of the deep ocean, every photon matters. Your descendants have learned to produce exactly the right intensity and duration of light to convey their message while conserving precious energy reserves. They've become living calculators, optimizing their communication for maximum impact with minimum cost. But bioluminescent communication comes with risks you never had to consider. Light in the darkness attracts attention from creatures that hunt by following luminous signals. Your descendants have had to develop sophisticated strategies for communicating without advertising their presence to predators. They've learned to use brief, targeted flashes that convey information to intended recipients while remaining invisible to unwanted observers. One particularly clever descendant has mastered the art of mimicking the bioluminescent patterns of other species. When threatened by a predator that hunts squid, it can instantly switch to displaying the light pattern of a toxic jellyfish, causing the would-be attacker to retreat in confusion. This kind of visual deception requires not just control over light production, but detailed knowledge of other species' signaling systems. The cognitive demands of this lifestyle are staggering. Your descendant must simultaneously monitor its own light production, interpret the signals of other creatures, assess threat levels, and maintain awareness of its position in three-dimensional space, all while operating in near-total darkness, where traditional visual cues are useless. Meanwhile, other branches of your family tree have taken completely different evolutionary paths. Some have moved into the most extreme environments on Earth, colonizing underwater volcanic vents, where superheated water, rich in toxic chemicals, creates conditions that would have been instantly lethal to you. These descendants have developed biochemical tolerances that border on the miraculous, processing sulfur compounds and heavy metals that would poison most marine life. The vent environments they inhabit are like alien worlds, dominated by bizarre creatures that derive energy from chemical processes rather than sunlight. Giant tube worms, ghostly white crabs, and bacteria mats create ecosystems unlike anything else on Earth. Your descendants have learned to navigate this strange landscape, hunting creatures adapted to conditions no surface-dwelling squid has ever encountered. The water temperature near active vents fluctuates wildly, from near freezing to scalding hot within the space of a few meters. Your descendants have developed the ability to read these thermal gradients like a map, using temperature differences to navigate and locate prey. They've become living thermometers, capable of detecting minute changes in water temperature that indicate the presence of food or the approach of danger. But perhaps the most extraordinary development involves descendants that have learned to use the chemical emissions from volcanic vents as hunting tools. They position themselves in the toxic plumes that rise from active vents, using their enhanced chemical tolerance to hunt prey that becomes disoriented by the sudden exposure to heavy metals and sulfur compounds. This represents a completely new category of predation, chemical warfare on a microscopic scale. Your descendants have essentially weaponized their environment, turning deadly volcanic emissions into hunting aids. The precision required for this technique is remarkable, as they must position themselves exactly at the boundary between tolerable and lethal chemical concentrations. The success of these vent-adapted descendants has opened up entirely new evolutionary possibilities. They're no longer competing with other squid for traditional prey in conventional habitats. They've claimed an ecological niche that no other cephalopod has ever exploited. This isolation has allowed them to develop in directions that would be impossible in more competitive environments. Some have grown larger than any squid from your lineage has ever achieved, their increased size supported by the abundant chemosynthetic bacteria that form the base of vent ecosystems. Others have developed specialized feeding appendages that allow them to filter bacteria directly from the water, supplementing their traditional hunting with a form of filter feeding that's completely unknown in surface squid. The most remarkable vent dwellers have developed symbiotic relationships with chemosynthetic bacteria, hosting colonies of these microorganisms in specialized organs that provide them with additional nutrition. They've become living ecosystems, carrying their food source with them wherever they go. This represents a level of biological integration that pushes the boundaries of what we typically consider individual organisms. But evolutionary success in extreme environments comes with its own costs. These vent-adapted descendants have become so specialized that they can no longer survive in normal seawater. They're trapped in their chemical oases, dependent on the continued activity of underwater volcanoes for their survival. If their vents go dormant, entire populations face extinction. This trade-off between specialization and flexibility echoes throughout the evolutionary history of your lineage. The descendants that have achieved the most dramatic adaptations are often the ones most vulnerable to environmental change. Meanwhile, those that have remained more generalized retain the flexibility to adapt to new challenges, but may struggle to compete with specialists in any particular niche. The mathematical beauty of this system becomes apparent when you consider the full scope of your genetic legacy. By producing numerous offspring with varied traits, you essentially placed evolutionary bets on multiple possible futures. Some bets have paid off spectacularly, producing descendants perfectly adapted to specific environments. Others have resulted in lineages that struggled and eventually disappeared. But the most valuable legacy may be the descendants that have retained the core cephalopod trait of behavioral flexibility, the ability to learn, adapt, and innovate in response to new challenges. These generalists may not be the most impressive specialists, but they're the ones most likely to survive whatever unexpected changes the future might bring. The ocean they inhabit is increasingly unpredictable, with conditions changing faster than many species can adapt. Your descendants that have maintained the cognitive flexibility to adjust their behavior in real time are proving most successful at navigating this uncertain environment. They're not just evolving, they're learning to evolve more effectively. Some have developed enhanced learning abilities that exceed even your impressive cognitive capabilities. They can modify their behavior based on single experiences rather than requiring multiple trials to establish new patterns. This accelerated learning allows them to adapt to environmental changes within their own lifetimes rather than waiting for genetic adaptation across generations. One particularly remarkable descendant has learned to use tools in ways that would surprise researchers studying cephalopod intelligence. It collects discarded shells and arranges them into portable shelters that it carries from place to place, essentially creating mobile homes that provide protection during vulnerable periods. This behavior requires not just problem-solving ability, but forward planning and resource management skills. Another has developed the ability to recognize and remember individual humans, distinguishing between those who pose threats and those who might provide opportunities. In areas where human activity is common, this descendant has learned to approach divers and researchers who have previously offered food while avoiding those who have shown aggressive behavior. This kind of individual recognition requires sophisticated facial processing abilities and long-term memory systems that rival those of much larger-brained animals. Your descendant has essentially developed a social intelligence adapted to interspecies interactions, something completely outside the evolutionary experience of your own generation. The cognitive arms race that began with your interactions with prey and predators has escalated to include human intelligence as a factor. Your descendants must now navigate environments where human technology and behavior create both opportunities and threats that change on timescales faster than biological adaptation can handle. Some have learned to exploit human infrastructure for their own benefit, using underwater cables and pipelines as highways for efficient travel between feeding areas. Others have discovered that human-made structures create unique microenvironments where prey concentrates in predictable patterns, allowing for more efficient hunting strategies. The most adaptable descendants have learned to read human behavioral patterns, recognizing when fishing activity, construction projects, or research operations create opportunities for easy feeding. They've become students of human psychology, predicting our actions and positioning themselves to benefit from the disruptions we create. This represents a fundamental shift in the nature of marine intelligence. Your descendants aren't just adapting to natural environmental pressures, they're co-evolving with human civilization, developing cognitive abilities specifically designed to navigate a world increasingly dominated by artificial structures and human activity. The implications of this development extend far beyond individual survival success. Your descendants are participating in the creation of new types of ecosystems where biological and technological systems interact in unprecedented ways. They're not just living in human-modified environments, they're actively shaping how these environments function. But the most profound development may be occurring at the level of cephalopod communication itself. Some populations of your descendants have begun developing proto-languages, systematic patterns of color changes and body postures that convey specific types of information. These aren't just emotional displays or territorial warnings. They're structured communications that approach the complexity of true language. Researchers observing these populations have documented what appears to be teaching behavior, where experienced adults demonstrate hunting techniques to younger individuals through specific sequences of visual signals. The young squid don't just watch and imitate. They respond with their own color patterns that seem to indicate understanding or request clarification. This emergence of structured communication represents a potential turning point in cephalopod evolution. If these proto-languages continue to develop, future generations might achieve levels of social coordination and knowledge transmission that could fundamentally alter their ecological role. The descendants developing these communication systems are beginning to hunt cooperatively in ways that surpass anything your generation achieved. They coordinate multi-stage attacks on large prey, with different individuals playing specific roles in herding, confusing, and ultimately capturing targets that would be impossible for solitary hunters to handle. But perhaps the most remarkable aspect of these developments is their speed. The behavioral innovations appearing in your lineage are happening within individual lifetimes rather than across evolutionary time scales. Your descendants are learning to learn more effectively, accelerating their own adaptation in ways that may allow them to keep pace with rapidly changing environmental conditions. This acceleration of behavioral evolution may be the key to cephalopod survival in an era of unprecedented environmental change. While other species struggle to adapt genetically to new conditions, your descendants are adapting behaviorally, finding new solutions to challenges as quickly as those challenges appear. The ocean. Your remains once enriched continues to flow through territories now claimed by these remarkable descendants. Your genetic contribution has become part of something that transcends individual existence, a living experiment in intelligence and adaptation that pushes the boundaries of what marine life can achieve. Your brief year of existence has rippled outward through time and space, contributing to developments you could never have imagined. The intelligence and adaptability you demonstrated have been refined, enhanced, and redirected toward challenges that didn't exist in your world, but define the reality your descendants must navigate. The currents that carry your descendants through these transformed oceans are themselves changed by their presence. Schools of your offspring have learned to manipulate water flow patterns using coordinated jet propulsion to create artificial currents that bring prey directly to them. They've essentially learned to farm the ocean, reshaping their environment rather than simply adapting to it. This environmental manipulation requires unprecedented levels of cooperation and timing. Hundreds of squid must coordinate their movements with split-second precision, each one contributing to a collective effort that benefits the entire group. The cognitive demands are staggering. Each individual must simultaneously track their own position, monitor the positions of dozens of others, and maintain awareness of the overall objective. But the most extraordinary development involves descendants that have learned to exploit quantum mechanical properties of light for camouflage. They've developed chromatophores capable of manipulating light at the photon level, creating interference patterns that make them literally invisible to certain types of vision. This isn't just advanced camouflage, it's physics-based stealth technology evolved through natural selection. The precision required for this quantum camouflage pushes biological systems to their absolute limits. Your descendants must control the spacing between reflective surfaces in their skin to within nanometers, creating destructive interference that cancels out specific wavelengths of light. They've become living optical computers, processing calculations that would challenge human engineers. Yet for all these remarkable adaptations, the most successful descendants may be those that have learned something simpler but more profound: how to survive failure. The ocean is unforgiving, and even the most intelligent predators experience setbacks. Your descendants that have developed resilience, the ability to recover from mistakes and adapt to unexpected challenges, often outlive those with more specialized but fragile capabilities. One such descendant has survived multiple encounters with predators that should have been fatal, each time learning something new about evasion and recovery. It's developed what can only be described as wisdom, the ability to distinguish between risks worth taking and those that lead to certain death. This kind of judgment comes only from experience, and experience requires survival. The ocean depths, where your story began, continue their eternal cycles, but they're no longer the same waters you knew. They're richer now, more complex, shaped by millions of years of accumulated intelligence from creatures like you. Your descendants swim through liquid history, each stroke of their tentacles connecting them to an unbroken chain of successful adaptation stretching back to the dawn of complex life. The story that began with your emergence from a tiny transparent capsule has become something vast and ongoing, a testament to the power of intelligence to overcome seemingly impossible challenges. Your brief existence sparked innovations that continue to ripple through marine ecosystems, proving that even the shortest lives can have consequences that echo through deep time. And somewhere in those vast waters, new capsules are splitting open, releasing the next generation of your lineage into a world of infinite possibility. They carry within their genes the accumulated wisdom of hundreds of millions of years, ready to face whatever challenges await in the endless blue depths of tomorrow. The cycle completes itself, as it always has and always will. Life as a squid might be brief, but it's never insignificant. Every moment matters when you're part of something this extraordinary. I hope you liked the video. Click on this one. Until then, see you soon.